Hi, I'm Josh from Georgia College, and today I'll be talking about polymorphism and some of its applications in Java. Alright, so before I jump into the polymorphism stuff, I want to introduce the two classes I'll be using in my examples, just to give some context as I move through the slides. The superclass is called animal, and it has two functions, move and can breathe. The subclass is called fish, and it also has two functions, move and is fish. So what is polymorphism? The idea behind polymorphism is that a superclass variable can reference a subclass object. For example, using the two classes I just described, animal and fish, both of the following declarations are true. Animal, animal1 equals new animal, and animal, animal1 equals new fish. Keep in mind that animal1 is referring to an animal variable, and it can point to either an animal object or a fish object. Polymorphism exists in the real world and can be used to help understand the concept in Java. Take for example again the two classes defined at the start of the video, animal and fish. This relationship makes sense because a fish is an animal, but not all animals are fish. A potential problem arises when using polymorphism. While an animal variable can reference objects of any class that extends animal, the variable may still only call methods defined by animal, regardless of the object the variable is referencing. For instance, if you create a new fish object referenced by an animal variable, you'll still only be able to call methods defined by animal. However, it is possible to call a function from the fish class if you typecast the call. This example corresponds to the slide you just saw. Before I show it though, I'll show the implementations of both the animal and fish classes so you can get a feel for what the expected output should be. The animal class has its functions move and can breathe, and the fish class, which extends animal, has its own move function and a function isFish. And when we look at the coding, we declare a new animal variable called fish1 and point it to a new fish object. Then we call fish1.move, fish1.canBreathe, and fish1.isFish. Now you can see by the error we're getting here, the type isFish is undefined for an animal variable. Now we can add a cast behind the fish1 variable, and that'll allow it to compile. So when we run the program, it prints off fish move by swimming. Breathing is one of the defining characteristics of an animal, and yes, this fish is a fish. When a superclass variable references a subclass object, another problem exists. What if the subclass has overwritten a method defined by the superclass and the variable calls that method? For instance, animal animal1 equals new fish, animal1.move. Now both the animal and the fish class have a move function. So will animal1 call the superclass version of move, or will it call the subclass version? In our second example, we declare two new instances. Animal1, which points to a new animal object, and animal2, which points to a new fish object. We then call both of their move functions. Now when we run the program, you can see that when animal1 calls move, it calls the animal version, and when animal2 calls move, it calls the fish version. As you just saw, the variable pointing to the fish object called the subclass version of the method. The reason for this is because of a process known as dynamic binding. Java performs dynamic binding when a variable contains a polymorphic reference. This means that the JVM determines at runtime which method to call depending on the type of object that the variable references, not the type of the variable itself. An important detail to keep in mind is that the is-a relationship does not work in reverse. While the statement a fish is an animal is true, the statement an animal is a fish is not true, simply because not all animals are fish. Because of this, you cannot assign a superclass object to a subclass variable. The reason for this is that fish objects have capabilities that animal objects do not. Note that unlike with the function calls from earlier, a typecast will not fix the error here. This example corresponds to the previous slide and shows what will happen when you attempt to assign a superclass object to a subclass variable. Here we've declared a new animal variable pointing to an animal object. When we try to assign the animal object to a fish variable, however, we get a type mismatch error as shown here. Now when we comment this line of code out, you can see that this doesn't throw an error. However, when you run the program, you can see that the compiler does throw a runtime error. The instance of operator in Java is used to determine whether or not a variable is an instance of a certain class. It represents a Boolean expression. If the object being referenced by the variable is a member of the class, then the expression returns true. Otherwise, it will return false. In this first example, we have an animal variable pointing to an animal object. The print statement will execute because animal1 is an object of the animal class. The instance of operator also understands the is-a relationship that exists between a class and its subclass. In the second example, we assign a fish object to a fish variable. The following print statement will also execute because fish is a subclass of animal. This last example corresponds to the instance of slide. Here I've declared two new objects, one of type animal and one of type fish. In the first if statement, the print line will execute if the object referenced by animal is of the animal class. In the second, the print line will execute if fish is a member of the animal class. Now when I run the program, you can see that both print statements execute. This is because animal is an object of the animal class and fish is an object of the subclass of animal. Well, that wraps up the video. If you have any questions or comments, feel free to post them below and press the subscribe button if you'd like to be notified when a new video is posted. Thanks!